Chapter 2 review. We are on page 71. Please write Chapter 2 review at the top of your paper. We're going to go through each section, and I want you to do one example at least for each section, okay? Now, some sections you will have more examples. For example, when we learned about multiplication and division, I wanted you to multiply with decimals, and I wanted you to multiply with fractions, and then I wanted you to divide with a decimal, and then I wanted you to divide with a fraction. So there'll be lots of examples for that section, okay? All right, 2.1, rational numbers. We learned what rational numbers were. This feels like forever ago, doesn't it? Yeah. In rational numbers, we learned that we have a big group called real. Inside that group, we have irrational. And we have?
Rational.
Okay, so rational numbers are anything that can be written as a fraction. Very good. That's decimals and fractions and all numbers, right?
Yeah.
Pretty much. Then underneath rational, we had? Integers. Now, what are integers?
Any number that's positive or negative.
Good, and they're whole numbers, right?
Yeah. Yeah.
So, for example, like -2, 6, 7, -8. I don't know, right? Underneath integers, we had?
Whole numbers.
Whole numbers are 0. Remember the O in 0?
Yeah.
Comma, 1, 2, 3. They're not negative. Okay? And no decimals. And then underneath that, we had? Natural. Natural is how little kids learn how to count. They don't start at 0, 1, 2, 3, so on and so on, right? However, we focused mainly on rational. Rational is anything that can be written as a fraction, which is almost everything. All right, so the first thing we did is we learned how to write things as decimals. Go ahead and write down 4 3/5, and then next to it say, write it as a decimal, okay? I want you to write it as a decimal so that when you look back at your notes, you know what you're doing, okay? 4 3/5, write it as a decimal. Do we see a whole number? What's the whole number?
4.
Okay, so make the 4 go in front of your decimal, okay? Now we're done with him. We can ignore him. I'm left with 3/5. How do I turn 3/5 into a decimal if I don't have a calculator? All three of you answer. Divide. Remember, fractions are just division problems, right? Okay, so let's go ahead and long divide 3/5. 3 goes inside, 5 goes outside. How many times can 5 go into 3?
None.
Can't. So we bring a decimal up and a 0. How many times does 5 go into 30?
6.
Perfect, right? Wonderful. So, 0.6, go snuggle that up here. My answer is?
4.6.
Good job. That's how we turn fractions into decimals. Yes.
Couldn't you also, you know that 5 times 2 is 10?
Ooh.
Just multiply it by 2?
Arrow, I love that way too. So Arrow noticed, yeah, I'll definitely throw Arrow a quarter on that one. Guys, Arrow noticed that 5 is a very easy number to turn into a type of 10, right? If you have a number, Arrow, that can turn into a 10, like either 10 or 100, right? Turn it into that because then it's super easy. Arrow said 5 times 2 would get you 10. Do it to the top as well. 6/10. 4 6/10. Isn't that what we got as an answer? 4 6/10. So if it can be turned into a 10 easily, do that. If not, how do we solve it? By dividing. That's okay. Some kids don't automatically see that and go, oh, I could get that to a 10 quickly. So it's good to know both ways, right? Because one way, you can't fail. You just divide, right? All right, let's do this one. We also learned how to write decimals as fractions. So in your notes, write -0.14 and then say write it as a fraction. -0.14, write it as a fraction. Okay, how do I write decimals as fractions? I had a little trick, remember? I think a lot of people remember. Christine, what is it?
Okay, so you write 14 as your numerator.
Good, so you write down what number you see, right?
Yeah, and then you count over how many places it goes over,
Okay, and that's 2.
and that's 2 zeros.
Good, so that's the form of 10 in your basement, right?
Yes.
Good. Now, 14 over 100, I'm forgetting a negative sign. Got to keep that with it, right?
Yeah.
Okay, can I reduce?
Yes.
How do we know? Look at my little rules up there. What could I take out of it? A 2? Let's try. Divide by 2, divide by 2. 14 divided by 2 is?
7.
100 divided by 2 is?
50.
Keep your negative with him, right?
We can no longer, we can not go down.
Are we done?
Yeah.
Yes. There's nothing times anything that equals 7 that would also come out of 50, right? Okay. All right. That was section 1. Seems easy now, doesn't it? Yeah. I think we had 4, didn't we? Maybe 5?
Yeah.
Okay, so look at the exercises down here.
Oh.
Wait, so that's 2.1?
That was just 2.1, okay? If you still struggle with making fractions into decimals and decimals into fractions, I have more exercises for you to practice on the bottom of 71. Okay, let's go on to the next section, 2.2. So in your notes, write 2.2, maybe make a line underneath 2.1 so you know you're starting something fresh. In 2.2, we added rational numbers. Now guys, adding fractions is something you learned in 4th grade. In 4th grade, we learned when adding a fraction, you need a common, super easy, right? The only difference in 4th grade math and 7th grade math is that now you've got a negative sign in there, right? The only difference is now you have to remember your rules. Signs are different, signs are the same, we just. So it's really that simple. Let's go ahead and write this one down as an example. Negative 7/2 plus 5/4. Got it written? Isaac?
You know what really irritates me is when they put a period after like a number column.
Yeah, it looks silly, doesn't it? Okay, you guys told me the first thing I have to do when adding and subtracting fractions is have a common.
Denominator.
What's a good common denominator with these?
4.
4, I love it. So can we keep 5/4 the same?
Yeah.
Okay, so how would I turn this 2 into a 4?
You multiply it by 2.
Hey, that video.
It's gonna live in it's gonna live in infamy now on my channel forever. Arrow, I love you.
He's gonna become famous over your sneezes, Arrow.
Yeah, this one's gonna go viral.
Yep.
Well, it's not your face, it's just the recording. All right, sweet babies, look up here. I've got common denominators. Signs are different, so we.
Subtract.
What's 14 take away 5?
9.
9/4. Now,
Negative.
why?
Because if there's one negative, it stays negative.
That's not the rule, but you're close.
Well,
Oh, you caught it.
oh, the bigger number has a negative.
Yes, the bigger number is 14, so we keep our negative. Now, am I done? Why am I not done?
Because you have to reduce.
You do have to reduce. It's irrational right now, right? Or not irrational. It's improper. I call it irrational because it's silly. Okay. How many 4s can come out of 9?
2.
1. Yeah,
2 whole ones?
Oh,
Keep your negative.
2 and 1. 4.
negative 2 and 1/2.
Negative 2 and a 4.
Huh? Oh.
Negative 2 and a 4th. Okay. So that's adding rational numbers. Okay, let's go see what else we can find. Let me move my little sheet down here. Looks like that's pretty much all we did. What happens when you have, decimals. Let's go do that. We're adding. Signs are the same,
So we just add.
right? Now, what do we need to remember when adding and subtracting decimals?
What?
Lines, decimals.
Yes! Oh my gosh, girl. Another one. Did you guys hear what Flora said?
No.
She said when adding and subtracting decimals, it's very important to make sure your decimals are lined up. Now we're just adding, right?
Yeah.
So does it matter which number's on top, which number's on bottom? Nope.
4.
Add them all up. 6 and 4 is 10. That is 4.
4.0.
Now,
Negative.
why?
Because because there's two negatives and you're just adding, so you give all the answer they all have.
Good. You keep the sign that everything has, right?
Yeah.
When in addition, so my answer is -4.
But wait. But it's different.
Yes, with multiplication, 2 negatives make a.
Positive.
We have to really remember there's two separate sets of rules.
I said that, but
then you did.
I'll be watching. You answer something else, okay? All right, guys, let's go ahead and go to section 2.3. We ready? All right, 2.3. We were subtracting rational numbers. Now, honestly, it's the same thing as 2.2. However, we have to change these into addition problems, right?
yes.
So we can use my rules.
Double negative.
Okay, go ahead and write this one down first.
Oh.
-4 2/5 minus -3/5.
Oh, it's
Ooh, so how do I turn this into addition problem?
Oh, you take the one
Bring the negative
sign and then you put it.
subtract.
So you're saying take that over there, make it a plus. But now it's gone, right?
Yeah.
So now it's -4 2/5 plus.
3/5.
Now, guys, when
Signs are different, so we subtract.
that's true, but listen. Do I have common denominators?
No.
Well, yeah, you do.
I do.
Well, yes. But
Is this an easy problem?
Bring down the
Okay, Taryn, signs are different, so we.
subtract.
Okay. Now hold on. Ignore this negative sign for a second. If I had 4 2/5 and I said take away 3/5,
Take
You bring
away.
down
Down 3 and 4/5.
Yeah, it'd be 3.
Oh, make it
Oh,
into
you
a
gotta
mixed
make it
number.
improper.
well, do I have to or can I just?
Or you
Bring
can
it down.
You can just
use your bring the whole thing.
you
This is kind of a tricky one.
just put the 4 off to the side.
Can we do that though and then just subtract these?
Yeah.
Will that work though?
No.
No. So this one's a little complex and it's hard to think about it. Like if you think about a number line, 1, 2, 3, 4, 5. Here's -4. -4 and 2/5.
Wait. If you're subtracting, there would be no 4.
I'm subtracting, so it's gonna go that way, right?
Yeah.
That means I'm taking 3/5 out of there. So I'm gonna have the 4 is gonna go away, right?
Yeah.
And we're gonna be somewhere in the 3s maybe?
Yeah.
The -3s? So you know what? Sometimes this is where remember when I taught you guys this lesson, I said that oops, I'm gonna undo all these. Remember how I said I like to turn these into improper? Sometimes.
Yeah.
This is one of those problems where I feel like if it was improper, it's easier to like fully understand the concept of it. It is. Except for sometimes is it easier to not change them to improper?
Yeah.
It depends, doesn't it? I feel like when we're adding, like if both of these were negative, guys, wouldn't that be so much easier?
Yeah.
Because then aren't we just adding?
Yeah.
Okay, that makes it easy. I like to turn this to improper just so that my brain can fully grasp the concept of it, okay? So what is -4 and 2/5?
22/5.
-22/5
Yeah.
plus 3/5? We still have the same common denominator. So now, what does 22 take away 3?
19.
19/5. Is it positive or negative?
Negative.
Why negative, Kaden?
Because there's one negative.
That's not the rule.
No. The bigger number has the negative.
Good. 22 is bigger and 22 is negative. So we're not done though. How many 5s can come out of 19?
3.
3 of them, that'd be 15.
4
And 4/5?
You almost stole your roll.
What can I not forget?
negative.
Yeah, I gotta keep my negative, right? Okay. How you guys feeling? Okay? I guess what I want you to realize is that 2.3, honestly, super easy. It's the same thing as 2.2. We just have to turn these into addition problems first, right? Let's do a decimal one. Write this one down. Both of these have been double negative problems.
I was gonna say negative.
How do I make it into one?
You bring the negative sign into.
Good. So now it's just 3.8 plus 7.45. We just simply add that, right? Okay, hold on. I'm kind of sad that I didn't give you a problem that wasn't double negative. So can we do this? 3.8 minus 7.45 instead?
Yeah.
It's still negative though.
Okay, so you're telling me that's not 7.45, that's negative 7.45. So give that minus sign to him and turn it into a plus.
Yeah.
Sweet. Now signs are different, so we
Subtract.
take the big number minus the little number. We have to remember to keep our decimals lined up, right? Now, do you see how that has a gap underneath the 5? Good kids. Okay, what's 5 take away 0?
Nothing.
5? So 4 take away 8 we can't do. 14 take away 8.
6.
6?
Yeah.
Agreed, everybody? 6 take away 3? Now, look up at your original problem. Who's the bigger number?
Negative 3.65.
Okay, there you go. Negative 3.65. How are we feeling?
Good.
Okay, here was our last section, 2.4, multiplying and dividing rational numbers. Go ahead and write that down, 2.4. Multiplying and dividing rational numbers. These are honestly my favorite because multiplying fractions is so easy.
You just multiply straight across.
Okay,
Make it into an improper.
But first you gotta change it.
always, right? This is a little different than addition and subtraction. You have to turn these into improper, okay? Some kids want to take this times this first, like if this was a multiplication problem, and then they would multiply these straight across. It's not going to work that way, guys. Multiplication doesn't work that way, okay? Now,
6 times 4.
this is not a multiplication problem. This is a,
Division.
go ahead and write this down.
Reciprocal.
Multiply by the,
Reciprocal.
you good. We're multiplying by the multiplicative inverse, which means to multiply by the reciprocal.
Yeah.
Huh?
Oh yeah.
Now, what do I have to do before I can skip, flip, and multiply? Abby?
You make it improper.
You make it improper. Ready, Abby?
Yeah.
You do. You make this improper. So times plus it. 6 times 4 is 24. Plus 1 more.
25.
25, 6, and negative, right?
Yeah. Can I get my candy?
Not yet.
4.
3 times 1 is 3. Plus 1 more is 4.
Over 3.
Okay. Now skip.
So 3/4.
Now, when I multiply fractions, this is why I love it so much. You just go straight across, straight across. 75? You're thinking of it as money, aren't you?
Yeah.
Because 3 25s are quarters, and 3 of them would be 75? Good thinking.
24.
Okay, negative or positive?
Negative.
Why, Flora?
Because there's one negative and it stays negative.
Goodness gracious, girl, you're going to have cavities from getting so many quarters today. All right, we're not done though, are we?
No. You have to do the thing.
How many 24s can come out of 75?
3. And
3 of them?
72. And so then it'll be 70. So it'll be 3 and then 3 24ths. And then that would equal 3 and 1/8. And you have to keep the negative, so it'll be negative 3 and 1/8.
Holy smolies, kiddos. Okay, so hold on. What are you taking out of the 3 and the 24?
3.
3.
A 3?
Yeah, so it'd be
Yeah,
1 and 8. So it'll be 3 negative.
Woo! I was waiting to see if you'd remember the negative. Good job, Kaden.
You want? No.
All right. That was dividing fractions. You ready to do another one?
Yeah.
Okay, let's multiply a fraction.
I worked hard for you.
Multiply a fraction. Let's do, where are the multiplication? Oh my gosh, you guys, on the quiz, we had something similar to this. Do you know what somebody did? Do you want to know what somebody did on their quiz? They said this is negative 4/9 minus 7/9.
No.
No. It's multiplication.
It's multiplication. If it's snuggled up next to a parenthesis, it means multiply. So it's just going to be negative 4/9 times negative 7/9. Without even doing the math, will my answer be positive or negative?
Negative.
Positive. Negatives make
Positive, because 2 negatives make a positive.
2 negatives make a positive. Good. So I can ignore my negatives. Agreed? What's 7 times 4?
28.
28.
What's 9 times 9?
81.
81.
Can I reduce?
Yes.
Take out a
9.
9?
No, not. that'd be
Sorry,
four.
9, 9. 4.
A 4?
No, it's gonna stick like that because it can't.
Is there anything? So 2's, there's nothing that come out that's a 2, right?
No. And it's not even.
Oh, never mind. It's odd and an even.
Yeah.
Okay,
so it's-
but what times what is 81? 9 times 9.
Yeah.
Is that it?
Wait, you can divide it by 9.
What's 28 divided by 9?
28 divided.
Close. You're thinking 27, huh?
Yeah.
So are we done?
Yeah.
Yeah, 28 over 81. Interesting.
I'm so smart.
Good job, children. Now, we just divided a fraction and we just multiplied a fraction. Let's do decimals now.
Oh, I don't like this.
Now, I like the decimals more too because it's just plain old multiplication, then you just count in the spaces, right? Do you have to line up decimals? No. Sometimes do they naturally line up? Like, will this one naturally line up? That's nice. Is there one? I want to find one that won't naturally line up. But I think they gave us everything that would. Oh, let's do this one. Number 23. Write this one down, please.
Oh, that's times.
It is times. That's not subtract, is it? Okay, here's what I saw a lot of people do on the quiz. They did this. 4.5 times 5.26.
No, you have to add a 0 behind the 5.
Do I, though?
Well, it's,
No.
but it's kinda like,
Here's what I'd like you to do. Put the longer number on top. Yep. So longer number. And does my decimal need to line up with the other decimal? No. But so here's what I want you to do. Put the longer number first. And then I want the last number of the long number and the last number of the short number to be what's lined up. Just like multiplication that you guys have done forever, right? Okay. Now let's just multiply. 6 times 5 is? 5 times 2 plus 3. 5 times 5 plus 1 more. Placeholder 0. 4 times 6? 4 times 2 plus 2. 4 times 5 plus 1. Add them all up.
23,
0.
7,
7.
6, 3, 2.
Okay, here we go. Here we go. Here we go. Most important thing right here. Ready? 1, 2, 3. 1, 2, 3.
23,670,000. Yeah,
Negative 23 point. Do I have to put the 0? Could I just say that? Yep. There we go.
Would it be wrong like on the test?
No.
Yeah, you were 26.
Oops.
He hasn't spoken this entire math.
Shh. Hey, hey, 7th grade, I'm recording. Don't interrupt. Okay, we just multiplied by a decimal. Now we need to divide by a decimal. And then we are done. Let's divide by this one. Go and write that one down. Okay. I think you guys were a little confused when I said to make this into a fraction. I had a lot of kids do this when I said make it into a fraction. They did that. Is that what I mean?
No.
Here's what I actually want you to do. Turn this entire problem into a fraction. Now remember, that fraction bar means what?
Divide.
And doesn't this also mean divide?
Yeah.
So can't I write 6.4 divided by negative 3.2? Yeah. Now, can I ever in the history of ever have a decimal in the denominator?
No.
How do I get it out of there? Everybody.
One to the right.
Kick it.
Take it.
Kick it like a soccer ball. How many places does it need to get kicked out?
Once.
So then if I do it to the bottom, I've got to do it to the kick it out once as well. So now I've got 64 over negative 32. Now, without even solving it, will my answer be positive or negative?
Negative.
Because one negative continues to be a...
Negative.
Okay. How do you know it's 2? Because...
32 times 2 is 64.
Yeah. Half of 32 is...
No, negative 2.
Good job. Negative 2. Good job, kids. Okay. That was all of chapter 2.
Wow, that was so cool.
So cool. You know what I want to do next? Unfortunately, the people on the video don't get to see this. Sorry, people on the video. But I'm going to show you the test. Not the one you'll be taking. It's part B. Okay?